Hello and welcome everyone. Thank you for joining us today for our webinar titled Why AutoML is Key to Your AI Transformation. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Rafael Cos is a community and partner maker at H2O.ai. Prior to H2O.ai, he was a technical marketing and community director and a developer advocate at Hortonworks. He was also the DataWorks Summit program co-chair for the past 3 years. Prior to Hortonworks, he was a senior solution architect and manager of IBM's worldwide big data enablement team. At IBM, he was responsible for the technical product enablement for big insights and streams. Previously, he held other positions in IBM where he worked on tools such as XMLDB, Federated DB, and Object Relational DB. Before I hand it over to Rafael, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Rafael.
Thanks, Patrick. Folks, today's topic is going to be around why automatic machine learning is key to your AI transformation. So I'm Rafael Cos. I'm the Director of Product Marketing here at H2O.ai. And instead of waiting for a whole big presentation on why, well, I try to summarize, some of the why here. So, part of the role of automatic machine learning is it can help democratize AI. It's about skills, it's about people, and anything we're doing around analytics, it's around accelerating time to insight, right? And as we look at that acceleration, some of that acceleration is clearly in speed, but some of that acceleration is in scale. How can we scale these AI efforts? And, part of this AI transformation is also about, looking at automating decision-making, right? Leveraging machine learning. And so as you're looking at automating machine decision-making, there needs to be trust in that decision-making, right? And so how do we establish trust in what's being built by AI is key to this. So in this presentation, I want to go through these themes in more detail. I'm also going to dive into a demo. And hopefully at the end, we have some time for questions and a further discussion. So let's get to our little bit more about H2O and who are we. So H2O is the open source leader in AI and machine learning. Our mission is to democratize AI for everyone. And we want to make your company into an AI company, right? So this AI can be a superpower, but oftentimes it sort of seems like it's sort of a superpower for the few, right? For maybe the big tech giants out there. And our mission is trying to help build tools to make this much more approachable and accessible by everybody. And in particular, we want to help make your company into an AI company. So let's talk a little bit more about this, democratizing AI. So as we look at democratizing AI, we want to help by building tools and working with the extended community and working with, we think open source is a key technology and approach to democratizing AI. So that's why we've built some open source tools that folks can leverage. Anything that we use in our automatic machine learning platform is an open source machine learning algorithm. But it's not just about having tools and technology. It's about partnering with you in your journey towards AI and working with you in an overall sort of community setting. And as we look at this mission to democratize AI, especially in these days, with COVID-19, it's not just about building better tech, but we also want to have an impact and work towards a social good. And so with that, we have an academic program. We're working with many institutions, but we also have a nonprofit area where we work with various folks in the community to kind of see how we can drive more impact in social good. There should be a webinar that's being posted soon around how we're working with the community and our partners to help and contribute to the fighting the COVID-19. So stay tuned for that. So if you haven't heard of H2O, we're a startup. We've been around since 2012. Just this summer, we got our Series D funding. We have a very diverse set of investors. We're about 220 and growing. About 20,000 companies are using our technology. We have a very rich open source community. We have three main platforms. Our H2O open source, that's sort of been there since the beginning. H2O Driverless AI, that's focused around automatic machine learning, and it's going to be sort of the focus of this talk today. And lastly, H2OQ, which is sort of focused around business users. One of the things that makes H2O an interesting company is we have this interesting combination of, distributed computing and algorithm development developers with a mix of leading worldwide data scientists, right? And in that mix of leading worldwide data scientists is a collection of Kaggle grandmasters, right? So here's a picture of 12 of the Kaggle grandmasters that are part of H2O.ai, and these folks are sort of at the bleeding edge, sort of looking at what technologies are evolving, what algorithms are evolving, what techniques can be leveraged, and we're looking to take those insights and drive that into the product and help make you take those insights and help make a product that makes you deliver better solutions in a shorter amount of time. So, clearly AI is transforming every industry, right? Whether it's looking at spend and more people sort of investing in AI as a way to drive more insights. The demand for skills is going up, as we see as, how many people looking for jobs in AI or looking for people with these particular skills. And, in these challenging times in particular, we're looking at how to best optimize sort of our process and where is our business going, right? So CIOs are definitely looking at AI as a key driver in this time. And as I mentioned, AI can be leveraged across many industries, whether it's financial services and looking at risk, collusion, transaction fraud, credit card payments, healthcare, whether you're looking at looking at product recommendations, matching doctors and patients, looking at medical claim fraud, looking at how flu might spread, right? And telcos with churn, marketing with better understanding your customer, getting a customer 360, getting an understanding of a 360 view of your customer, looking at maybe what's their next best offer, what's the next best action to kind of take with the customer. So there's many use cases. There was a webinar last week on AI transformation that kind of focused a little bit more on the use cases. We have some links on our website. You can kind of dive deeper into some of the different use cases. But as we look at these AI and how it's being adopted, we're seeing a couple of different trends. One, we're seeing AI graduate from sort of an innovation lab to an enterprise approach, where maybe at some point, and many of you might be in different phases of this journey, right? But we are starting to see the trend where it's graduating from an innovation lab with a small set of data scientists maybe experimenting on a couple things, and kind of moving it more to an enterprise approach, where we're looking at how AI can take and help drive the business across the business. And with that, we're seeing people kind of move from maybe tens of models, maybe 100 models, to producing an AI factory, right? Where they look at maybe generating more and more models, and which is great. So they're seeing that business value, but at the same time, where do they get the talent to keep scaling this AI effort, right? And we're seeing, enterprises look for an infrastructure neutral enterprise approach, right? And so, as you're looking at whether you're doing on-prem or in the cloud, you want to have the flexibility to leverage the appropriate infrastructure and have the flexibility to move from one infrastructure to another, whether it's on-prem to cloud or from one cloud to another cloud, right? And what's an AI approach that can give you that flexibility? with AI, it's always challenging to manage change, right? And any transformation, change is going to be part of the challenge. And then, in particular with AI, it's about how you can not just kind of look at the technology, but solve a business problem. But actually, as you go to implement it, there's probably cultural changes that might need to happen within your enterprise, how you change your processes, how you train your people to really kind of be able to leverage this, right? And kind of going from exploring and experimenting with something to kind of putting into production, right? And do you have the infrastructure to kind of do that? And lastly, how AI can, as we look at democratizing AI, not only do we want to kind of be able to kind of help data scientists and from senior data scientists to junior data scientists, but how do we get other business users involved, and how can they leverage it, and how can they start also leverage being able to get projects started with AI? And so with that, how can we help you and your company become an AI company, right? And help you accelerate you in this journey, right? So kind of looking at that speed and scale of your AI initiatives in that journey, helping build trust along those ways. And that's where we think automatic machine learning plays a key role, right? Because it can streamline many things, kind of get you that speed and scale, right? But also, getting the right AutoML that can kind of help with also building trust and providing the ease of deployment is key. So as we look at this transformation journey, clearly it's about, data. Data is key in this journey, AI and the technology behind it, people, right? And getting the skills on your team, getting them to understand these new initiatives to be able to execute that is going to drive this transformation. And when you're driving this transformation, what are you doing? What's the goal? I mean, clearly the goal to me is to accelerate time to insights. And the way we're accelerating time to insights by transforming decision making. And so the AI is actually playing a role in transforming decision making as we look at leveraging machine learning models to automate some of this decision process. And so as we look to accelerate that, we want to do that faster, and we want to be able to scale those efforts. And we want to be able to get this into many people's hands, as many people as possible, but also make it easier so more people can kind of get on board. And as people are getting on board and we're looking to transform this decision making, we want to build trust in that process. So if we dive deeper into that AI journey, right, we want to create a data culture. We want to make sure we are asking the right questions. We want to extend with the extended community. And some of that is helping your people learn, but that's also leveraging open source and the power of open source and AI to bring those benefits into your enterprise. We want to make sure you want to kind of evaluate what technology you're leveraging, whether it's on-prem or in the cloud, and having the flexibility to use the right AI wherever you choose your infrastructure. And lastly, we want to help build trust in AI. And these 5 topics were covered in more detail in the webinar sort of last week. So as we look at that journey, machine learning plays a key role, right? But as we're looking at machine learning in this journey, there's a couple of different challenges that different enterprises are running into. And we mentioned how people is the key in that transformation. And so it's how do we find those people, getting the talent. Sometimes it's finding those data scientists. They refer to them as unicorns because they're hard to find, right? And so as you want to look at speeding these efforts or scaling these efforts, that might mean that you might need more of these people, right? And so how do you find them? How do you enable them? And is there a way to kind of take your existing team and transition them towards this technology? Time. I think time has clearly there's the speed and acceleration dimension of it, of the people, but it's also of the technology. How much time does it kind of take to kind of work through a use case to kind of get to a point where you have a machine learning model you can take into production, right? And some of that time is in the tooling, right? And some of that time is in building, right? So, AI can be very compute intensive. And lastly is, as we talked about sort of automating decision making, this automated decision making, in order for it to go forward, in some industries this is regulated, so you have to explain how the models are working. But at the same time, as you look at taking on that cultural challenge in automating decision making, you want to help build trust. Because if you're not going to build trust, then you're not going to be able to go forward in deploying these machine learning technology. Right, and so now I want to talk a little bit about some of our products here at H2O.ai and how they can help you in this particular journey. So we have our open source technology that helps with distributed machine learning. That's H2O, or sometimes we treat it as H2O3. We have sparkling water that works with Spark to do data prep. So this is, looking at doing machine learning at scale on Hadoop clusters, on Spark clusters, on Kubernetes clusters. Then we have Driverless AI that's really focused on automating the whole, as much as possible, the end-to-end machine learning workflow, and leveraging both CPUs and GPUs, right? And lastly, we have H2OQ, which is looking at our third generation of machine learning platform, which is more focused on providing an interface for business users and automating the descriptive analytics and the journey towards leveraging AI and predictive analytics. So we're going to focus today on H2O Driverless AI. And a little bit about our products and technology. So Gartner this year released 2 Magic Quadrants, one around data science and machine learning, and the other one around cloud AI for developers. So these 2 Magic Quadrants are focused on machine learning and AI. And H2O is one of the few vendors that participated and qualified for both of them. And on the data science and machine learning Magic Quadrant, we were named the vendor with the strongest completeness of vision of the entire quadrant. So that means that we were furthest to the right in vision. And and Gartner pointed out a couple of different strengths. One is automation, right? As we kind of look at speed and scale, that's key. 2 is explainability, to kind of help with building that trust. And 3 is high performance machine learning components, right? The fact that we can either scale large clusters or leverage the compute, the CPUs and the GPUs to kind of accelerate this machine learning. And as we looked at the Cloud AI Developer Service MQ, one thing to point out, we're the only if you sort of ignore the various cloud vendors, we are the leader there. So as you're looking at a multi-cloud solution, or a solution that can both go cloud and on-prem, H2O.ai is sort of uniquely positioned there, right? And so that Magic Quadrant, they pointed out, again, sort of automation is a key strength of H2O.ai. The ease of use of the product and the flexibility and power we have to explaining models. And lastly, the stellar, excellent customer support that's provided part of H2O. So, yes, we have these strong products, and there have been recognized by the industry. And this is one recent report in Gartner that's come out. And by the way, if you want to get more details on this report, it's available on our website. So you can kind of go there, select it, and then you can download it. So you can kind of get more details from there, but this is one of many, right? So, whether it's Gartner or Forrester or whether it's, other sort of news media industry, H2O consistently gets recognized for its strength in its products, in particular around automatic machine learning. So as we look at automatic machine learning, and your journey to AI and how to make your company into an AI company, automatic machine learning plays a key role, and we want to be able to have a single platform to do machine learning and AI we want to be able to leverage AI to do AI, and we want to deliver insights and interpretability quickly, right? We want to reduce that time to insights. And part of the challenge in automation is sometimes, hey, I have all this automation, but it can become rigid, right, or limiting, right? So as we're looking at a platform to automate this process, I think a key consideration is being able to have a platform that's open, that you can customize, that you can extend, that you can pull in additional capability as necessary, right? And it's extensible, right? That you can kind of bring your knowledge, your domain knowledge into the platform. So with this, driverless AI is sort of positioned to solve, the talent, time, and trust challenge, right? And the talent by being able to democratize some of the knowledge, taking the skills of our expert data scientists and capital grandmasters and automate that in a series of tools. And so for junior data scientists, you can help them, build better models in a shorter amount of time. And for your expert data scientists, it's really about, keeping them focused on top priorities, right? So maybe taking out some of the tedious nature and be able to help them be more productive. And so hopefully you can kind of get them focused on additional sort of use cases. And, we want to sort of reduce this from, months to hours and weeks, right? So the time is, automating this. And sometimes as you look at the automation, you can kind of look at that as a two-sided coin, right? One way to kind of look at automation in data science and machine learning is, hey, you're using some kind of notebook or IDE to do development. Let me give you a way to kind of code faster, right? And there's some folks and vendors in the industry where they've taken that approach. And the other side of that coin is, what can we automate, right? And instead of you coding faster, can we optimize this and make decisions ourselves, right? And that's where can we leverage AI to do AI, right? And so that's the approach that we're taking this in this automatic machine learning journey. Sorry. And the last thing is being able to not just automate the building of models, right? But we want to automate the generation of explanations of models, so to kind of help accelerate building that trust. So driverless AI accelerates this time to value, right? And so it kind of looks at this machine learning workflow and automates some of the exploratory data analysis by generating automatic visualizations, and we'll see some of this in the demo. Being able to give you fast and accurate results with minimal sort of input, and kind of leverage some best practices in how to start with experiments, which algorithms can leverage, and doing the tuning, and not just kind of building the models, but making it easy to understand the results of those models, right? So we automatically generate sort of best practice explanations in the industry. And lastly, we want to have a tool that you can leverage to make it easy to deploy, right? So, whether your end production environment is Python, Java, or C++, or R, or if you're sort of doing batch scoring or real-time scoring, or you need to have a fast millisecond deployment, we want to kind of build you something that's enterprise ready, easy to deploy, and meets your latency requirements. So for those folks who maybe are new to machine learning, or when you're saying sort of automating machine learning, this is what a typical machine learning workflow looks like, right? So you need to get some data. In particular, this is sort of a little bit more focused on supervised learning. So I'm going to learn by some example. You need to prepare the data. You do classic data cleansing that you would do with any analytics. But there's also some special data preparation for getting the data ready to be fed into machine learning, right? So, and then once you do that, there's this whole process of, selecting algorithms, tuning those algorithms, what score you're tuning those algorithms for, doing feature engineering. And feature engineering is the technique that's used to find the signal and the noise in various features. So sometimes applying different mathematical techniques, across one feature or multiple features to try to find the signals. At some point, you're going to have a model, explain the model, generate reports on the model, and get something that's ready to actually deploy, right? And so this can be very time-consuming and complex, and this is part of the thing we want to figure out how to speed up and at the same time scale the efforts around. And so what does it look like with Driverless AI? So, Driverless AI out of the box comes with all these different connectors, and we have some extensibility, to connect to additional data sources, bring the data in, start your journey around exploring the data, get into this automatic machine learning process where we sort of suggest algorithms, tune them for you, do the feature engineering, and do it in such a way that's extensible, right? So this is this step 4 here at the bottom. You can bring your own recipe, which is part of the extensibility capability, where you can bring additional algorithms or optimize a model to your score in your business, or bring your insights as far as feature engineering into the process via additional transformers, right? So, Driverless AI not only has this automatic model optimization component, but it's an open, extensible model optimization component. And lastly, we want to kind of generate explanations and documentations on the model and automatically generate a deployment-ready, low-latency scoring pipeline to put into production. So if we take a little closer look on the automatic model optimization component, this is where we want to make and leverage the capability of your own enterprise to help make it your particular AI, right? And so sometimes this is referred to as, this feature is referred to as bring your own recipe, BYOR. And there's some webinars and tutorials out there that can dive deeper in here. And so I think, to me, this was best illustrated in a session that Goldman Sachs did with us late last year, where they were talking about their expert data scientists and being able to speed and scale their machine learning efforts. But they sort of want their cake and eat it too, right? They want the power addition, but they want to be able to customize it because they have particular domain expertise around additional algorithms that might be interesting, different additional feature engineering, how they want to optimize. And so they have their intellectual property, that's their secret sauce. So they want to kind of be able to blend that with the automation that we're already doing, right? To get that speed and acceleration and that scale. And so that's where this open accessible platform allows you to pull in additional things from an open catalog that we have. So you can kind of go to catalog.h2o.ai and see additional recipes you can bring in. There's some tutorials you can learn from. Or you can kind of make your own additional recipes to kind of mix and match with what's happening with our automatic model optimization. As we look at deployment, one of the interesting things that H2O does is it produces a deployment-ready artifact, right? And this deployment-ready artifact is built around, the notion that you train once and you run anywhere, right? And so we want to be able to go through this automation, and not just in the training phase, but like help facilitate the deployment. So we want to be able to package the model and the feature engineering into a compact format, right, that can give you the low latency scoring. And we want to make it portable. And part of portable is whether it's cloud or on-prem, right, whether it's batch or real-time, whether it's in the server room or at the edge, right? We want to give you this flexible and embeddable environment that you can deploy to whatever your situation is or however it evolves. And one of the challenges in deployment is oftentimes many different types of algorithms are used, whether it's XGBoost or LightGBM or TensorFlow, right? And so as you deal with these different tools, then your IT environment also needs to figure out how to support them into a deployment. And then if you want to switch between one or the other, that IT infrastructure also needs to sort of switch. And the nice thing is this Mojo, which is our model object optimized is this deployment-ready artifact that gets produced by driverless AI is algorithm dependent, right? So independent of which algorithm gets used, will give you one common runtime that makes it easy for you to go between things, and your IT and DevOps folks know how to kind of get this infrastructure in place, and then it makes it much easier to kind of deploy models. And when you make it easy to deploy models, but these models are also fast, right? And it can meet your low latency requirements. So what does that look like, right? So, whether you're using H2O 3 in the open source or driverless AI, it gets you this sort of Mojo deployment artifact, and then you can take that with your corresponding runtime, and then you can score whether it's a batch in real time. And once you deploy, you can kind of monitor that and look for additional changes in your data. So look at drift in the data, and then at some point decide to retrain. So next, as we look at building this model and trying to take it into deployment, we want to accelerate this building of trust and understanding. Not just accelerate it. We want to kind of make sure it's core part of what's happening, right? Because as we're automating this decision making, we want to make sure that the scientists can understand why certain decisions are being made, and at the same time can easily translate that into explanations that business leaders can understand. So there's a book out there by Riley on Introduction to Machine Learning by Patrick Hall and Navdeep Gill. I think this is available for free on our website. You can kind of download it and kind of take a deeper dive. For those folks who like to get hands-on, there's also some tutorials that kind of walk you hands-on through some of these explanations. We also have some upcoming webinars on explainability and building trust with AI. So stay tuned for those. So now I'm going to switch over to a quick demo. Right, so here I have a model that was sort of running before, right? So this is the driverless AI user interface, right? So I'm going to go over to datasets, and I can click on various connectors. So this is a short list, but we have over 14 different connectors, relational databases, cloud data sources, where you can kind of go and get data. We also have this flexible data recipe that allows you to leverage Python to connect to any of these data sources and do some additional data wrangling and data cleansing. And today we're going to work with the credit card data set. So as I look at my credit card data set, let's take a quick look at it. And so this credit card data set, we have a profile of the person, right? Their limit balance, sex, education, marriage, and age. And then we have some historical features, right? These features or columns are the attributes that we're looking to see a particular pattern around, right? So what we're trying to actually predict is see if someone's going to default on a payment. So one is actually the folks who have defaulted. So most of the time people don't default, right? And so we're going to look at a couple of other historical features, right? So this is payment history over the last 6 months. Right, their bill amount over the last 6 months, and a history of how they made payments. Did they make it on time? Did they make it early? Were they late? If they were late, how late were they? Right, we can see a sampling of what the data actually looks like. Right, and then we can kind of continue our exploration of the data by looking at some visualizations, right? And so what's happening here is that we're automatically generating some visualization. So we're using AI to do AI. And so sometimes it's 6 graphs, sometimes it's 12 graphs. It really depends on the patterns that exist. So, part of the data scientist is understanding and growing their understanding of the data, and and creating hypotheses and validating those hypotheses, but it's also trying to understand, the quality of the data, right? So, if there's outliers, okay, what are those outliers? And having a conversation with the folks in the line of business, if these make sense. So here we're looking at bill amount 5, we're looking at pay amount 3, bill amount 4. We can select one of these and, maybe have a conversation with the line of business that says, hey, is this within range? Does this make sense? Right? Maybe there's a conversation. If it doesn't make sense, maybe we need to clean up some data. You can work with the data engineer that produced this, or maybe there's a discussion with the data engineer on where did this come from? How did you produce it? What were the various data sources, right? Because one of the things is, with any analysis of data is, garbage in, garbage out, right? So, we also kind of looking at things like, because we're doing supervised learning with machine learning, looking at a correlation graph, right? So looking at the relationships that exist between the various features and how strong they are. So any of these are described, right? So typically in school, when you got math, if you saw red was bad, right? But in this case, actually red is good. So red shows that there's high correlation. So we can kind of choose a particular value, and then we can see, okay, you see there's a strong correlation with payment 3, and some weaker correlation amongst some of the other ones, and there's a weaker correlation around limit balance. So we can kind of use this to filter the strong correlations, look at the relationships. Sometimes you do experiments just to try to identify which features are important. So we can continue exploring the data, having the conversation with the line of business, with our data engineers, making sure the data is good. And once we're ready and to actually take the next step, we can actually go and create an experiment. And as we create an experiment, we can do a prediction. So we can say, this is my demo experiment, right? I can select a test data set. Right, so in this case, here's my credit card test data set. If I wanted to drop some columns because I knew maybe there's some data leakage, right, or some, I wanted to kind of get focus on it. So at this point, I'm going to let it work on all of them. I can select, where's the example that I'm trying to learn from, right, my label. So I give it my label, and again, we're seeing the power of AI to do AI. So it figured out that this is a classification problem. Given the data and our target column, it's suggesting AUC as a score, right? So this is what it's going to optimize to. You can override that if necessary, and then we can give you some, high-level nods that you can use to jumpstart this whole process, around accuracy, time, and interpretability. For the expert data scientists in the room, don't worry. There's actually more nods available for you to control more things. So there's more fine-tuning that you need to do. But for the folks who may be more novice, this is a great way to sort of get started and leverage the recommendations provided by the tool, right? So here, accuracy really ranges from 10 to 1. So we give you some default recommendations, and they really depend on each use cases. So here we're seeing accuracy at 5. And so accuracy has 2 major impacts. One is around the model. So here it's suggesting a constant, a GLM, a LiGBM, a XGBoost GBM, right? The level of ensembling and the types of feature engineering. So as I kind of go up on accuracy, we could potentially see a change in the feature engineering techniques that are being leveraged. The ensembling definitely went up, right? I think the GLM model was sort of removed, right? So, time is a matter not in minutes or hours, it's about effort, how many iterations we're going to do, right? And interpretability, the interpretability/complexity is, all our models are interpretable. It's really kind of looking at how complex of a model that we're looking at building. So there's a little bit of a yin-yang effect with interpretability. So as we go up with interpretability, we're probably definitely going to reduce the set of feature engineering, right, that's being leveraged. The level of ensembling probably will go down, and if we kind of take it all the way up, we'll see at some point that it completely removes the ensembling completely, right? and the setup feature engineering was greatly reduced. So I'm going to take this back to 7, and for the sake of the demo, I'm going to reduce the time to 2 and just kick off an experiment. So let's launch this. So this environment is running with CPU memory and some amount of GPUs. So this is actually running with GPUs. So Driverless AI runs with both CPUs, but also can leverage GPUs to accelerate the process of building models. And so initially what it does a series of checks, right, to look at your data, your training data, your test data, see if there's any shifts between them. It might suggest values where they see some shift between the data. It'll check for data leakage to see if the answer is in the features. Right? So if you have some data leakage, you can very quickly get to a model that's 99% accuracy, but in some ways you're cheating, right? And so it checks for things like data leakage, and then goes through a process where it starts looking at different models, what are the hyperparameters it can leverage, and then starts building models here in the leaderboard in the left. So here, about a minute into it, we've built 3 models. This one is saying that the current model is at a 0.77. This is the winning model at the moment. It's using LightGBM, but we can hover over each one of these. So, you know, these are all 3 are LightGBM models. This is showing the variable importance for the current winning model. And as the models keep evolving, you know, the variable importance will continue to change. At this point, it has done it's using currently the original features, but this genetic algorithm that's evolving the tuning, the algorithms, and the feature engineering, and then keep exploring more feature engineering techniques. And we give you a collection of key metrics to kind of look at sort of your confusion metrics and, you know, look at true positives and true negatives and, you know, what's your false positives and false negatives. We also give you graphs, automatically generate graphs around precision recall, lift, gains, KS, right? And so this process is going to continue for a while. And so, you know, a few more minutes in here, and it seems like LightGBM is still the winning model, but now we're starting to see things like additional feature engineering, right? So you know, number 38, we can see weight of evidence with, you know, P0 is a feature engineering technique that's being applied. So anything above 25 is something that's leveraging a feature engineering to kind of improve the model. And so we see a whole collection of them. So for the second time, I'm going to do a little bit like the cookie show. So I'm going to switch over to an experiment that is already done. And there are also, you know, in here we have the notion of a project. So we actually created a project already. So here's a series of models that I pre-built in the past. And I'm going to look at one of these models, right? And so when the experiment is done, you can kind of see the winning model. So here's an ensemble model of 2 models. And we give you this series of buttons where you can kind of look at next steps. So we can go and interpret a model. We can download an auto report. So as we look at downloading the auto report, this is a report that's used to kind of automatically look at what was done in the experiment, right? So in this experiment, you know, this was how it performed with AUC-PR as a metric. You know, what settings were used, what software was used, right? What was the configuration of the environment, you know, and it's a very detailed report. You know, you can edit the report, so we can say, hey, this is a very time-consuming process, right? But you know, we can give you lots of details about the methodology that was used. Here's all the steps that I went through. Gives you a description of all of them. You know, we can dive deeper into the various hyperparameters, right? Some of the cross-validation that was done in producing it. So it's a very detailed report of what was done. Here's some more information about the feature engineering, right? But this report is automatically generated for you. And we can also go look at and interpret a model. So we can kind of kick off an interpretation and so kind of look at what a model explanation looks like. So as I look at a model explanation, here's a whole dashboard that gets put together around model explanation. Some of these are directly on the model, right? So we can look at things like feature importance. And so here in the feature importance, we're looking at, the feature importance with the all the feature engineering, or we can kind of look at the feature importance on the original features. In a similar way, we can kind of look at Shapley values, partial dependence plots, disparate effect analysis to look at potential bias between, maybe how we're looking at loans between males and females. Look at what-if analysis with sensitivity analysis. And then there's some additional techniques around surrogate models. We also give you this nice interactive dashboard, so you can kind of look at sort of in a case-by-case basis what's happening, right? So in this case, we can actually look at an individual who applied for a loan, right, and give you a decision path. It's like why are we going to reject you for a loan maybe this time? And we can look at reason codes, so you can see that from this decision tree, it's like, look, because you missed your last payment, because you missed payment 2 months ago and 6 months ago, this is why we're getting at this particular threshold for a prediction. And typically, the way the important features are global, so those are the yellow ones, but the gray ones are the local ones. So in this particular individual's case, it was not only was it the last payment that they missed, but that they missed the second, third, fourth, sixth. So it seems like this person's had some issues in missing payments, and that's what's driving the decision for this particular model, right? So as we look at this, at the end, as we look at our projects, we can kind of look at the different experiments that were done and actually compare them to each other. Get back to projects. I can select a couple of these and compare them to each other. So I can run different experiments. Some of them are using the core original features. Some of them are using more additional feature engineering techniques, compare the various metrics side by side. So I can look at, the various ROC curves, the confusion matrix, and all these things to kind of decide which model I want to kind of put into production. And so once I want to put something into production, I can look at this final model and kind of generate a final scoring pipeline, right? So this is where you can do it via Python or via this Mojo one, and we have various runtimes, whether it's the Java runtime, Python runtime, or our runtime. They can deploy this Mojo. So as we go back to our presentation, so how is this technology being leveraged by some customers in some different use cases, right? So this is a use case around Accordo Certo, and so they're looking at building a model that's 76% improving their repayment, right? And they've seen a great reduction in leveraging automatic machine learning to reduce their time to deploy a model, by 70%, which is fairly dramatic, right? And so this is a platform that's looking has been saving a significant amount of money in the range of millions, and looking at being able to reduce the debt around in Brazil. So kind of taking a new approach about how they evaluate the risk that someone has, and how much who can make back payments. And we cover various use cases, not just in financial, but also in sort of a marketing, and kind of look at, hey, I want to look at different call center records, looking at what is the intent of someone calling into a call center, and who should I focus on to provide them not just the best service, but who is also most likely to want to buy. And so they've seen some dramatic improvements in their ability to identify these people, which is then driving cost savings and generating more revenue for their campaigns. Right. So and this is all sort of working 10 times faster than it was as they started to leverage automatic machine learning. And again, this is just another use case around looking at an enterprise that's looking at supply chain optimization in case they're trying to optimize supply chain around blueberries, especially with different shifts in times and demands. Given where the demand is, where the suppliers are, what's the state of my capital? Because in this case, their capital is perishing. How do they route it, right? So they're looking to again reduce the time in getting productivity and value out of models, right? So they reduce their time that it takes to build and deploy a model from 3 to 5 months to 3 to 5 weeks, leveraging automatic machine learning. So you can get a lot more details on these on our website. So Driverless is this platform to help your company make your own AI platform. It's a single platform for AI machine learning. It leverages AI to do AI, to drive insights and interpretability, to automate and scale this capability. It's an open and accessible platform, right? So as we look at the role of automatic machine learning to accelerate, AI, it's really about accelerating time to insights. It's democratizing AI and getting it to more skills. You want to be able to scale your efforts and at the same time build trust. And you're doing all this to help make your company into an AI company to help automate decision making to get more value and optimize your whole business. So we have a whole set of resources to help you get started. I think the slides will be sent out so you can kind of kick them on. So there's a 21-day trial, there's some free tutorials, there's webinars and meetups, and there's some more information about our various industries. So with that, that's sort of summary of our session for today. It seems like there's a few folks that have joined, so I want to turn it back to Patrick and see if there's any questions on the line.
Yes, we certainly have a good number of questions, so we'll try to get to all of them with time permitting. The first question I'm seeing here is, hi, your excellent demo focused on a single table of data. Can you tell us a little bit about how your tools would provide support in a situation where we start from more complex data in many different tables?
Yeah. So Driverless AI is focused on automating the building of models, right? So, but we do understand that data, there needs to be a whole data preparation phase, right? So your company probably already is leveraging some data preparation tools. And in some cases, some data scientists, their preparation tool of choice is Python, right? So if you have multiple data in, say, databases, you can use our JDBC connector to access the different tables in the database, do the joining and transformation to kind of load it into an environment. Or you can kind of load data from multiple data sources into the tool, and then say you want to apply some joining, cleansing, transformation of data. So we have this notion called the data recipe that allows you to plug in additional Python code to do the transformation and the manipulation of data to get it ready for building models.
Okay, great. Next question is, can the Mojos be deployed on AWS SageMaker?
Yes, absolutely. So we've done some integration with AWS, and so we actually in the product out of the box, you can we have a one-click deploy to kind of deploy to AWS Lambda. But if you want to work with SageMaker, one of the nice things about this notion of a Mojo, it's very embeddable, right? So if you want to embed it in SageMaker today and tomorrow in something in Google, and the next day on on-prem near your device or inside an application, the Mojo can be deployed in multiple environments.
Awesome. How about with Databricks? Is H2O interoperable with Databricks?
Yeah, so as you look at Databricks, H2O is one of the few third-party tools that kind of integrates with Databricks, right? So, and we have multiple sort of different integration points that you can leverage within Databricks. So Spark is a great tool. It has many different capabilities from data prep to machine learning to SQL to graph processing, but maybe it's not the best at any one of those things, right? And if I look at something like Spark, the great power of Spark is in data prep. And so if you want to use Spark to do machine learning, and then it's like you could potentially use Spark to do all the data prep, figure out your data, do your data cleansing, as someone sort of mentioned before, and then kind of bring it to to a tool to kind of automate the building of the models. So in this case, if you're using Databricks on Azure, you have your data, you pair it in S3, we have an S3 connector, we connect to it, start building models. Or if you have Databricks in Azure, again, we have a connector, we can grab it, you start sort of building models from there.
Excellent. Next question here is, how does the open source offering from H2O AutoML, how does that compare to driverless AI?
Yeah, so H2O, so there's first generation of automatic machine learning was done in our open source with H2O AutoML, and it's still a great tool. We keep developing and investing in it. So when using H2O AutoML, many times you kind of potentially can be looking at doing machine learning at scale. So if you're looking into scale into, terabytes and petabytes of data, there's a limited amount of tools that can build models at that scale. And, if you're looking at building, models at that scale and also automating it, H2O AutoML is a great sort of approach for that. Now, if you look at the differences in the automation, right? So if we're looking at exploring the data, if you're looking at, as you're kind of doing the automation, maybe you also want to automate the feature engineering. So there's no necessarily automatic feature engineering in the H2O3 AutoML. And again, kind of looking at automatically generating explanations, right? So there's definitely automation there. It's our first generation of automation. It can scale. But it doesn't have the breadth of automation that's in driverless AI.
Great. And how about, at a high level, how does the interpretability lever work in an experiment? Does it exclude certain techniques such as neural nets? Does it allow less degrees of freedom for others, like less trees or fewer splits, etc.?
Right. So there's definitely those sort of tuning techniques you can do. So I would sort of view it in two ways. Even before you run an experiment, you have a sort of choice, right? When you look at how interpretable you want to make a model, as you turn up that knob, it starts excluding different types of algorithms being considered, right? So maybe it'll exclude a neural net from the algorithms as you want to look at understanding the models. It definitely excludes feature engineering techniques, right? But you can also kind of look at reducing the complexity of the model to make it more interpretable. And there's lots of different sort of tuning options. There's a great tutorial that kind of walks you through it. That's on our website. I would definitely check that out.
Awesome. Next question. Can you also use driverless AI in production?
I'm not sure I understand the question. Of course you can use driverless AI in production.
Yes, I
more
agree.
To that question.
Yeah. So how is your development with data table? How will it improve your product? Okay,
so data table is a tool that's out there in the open source that we have been involved with. There's a data table in R where we have some of the key developers that are part of that, and then there's a version in Python where we have some of the key developers around that. And so with data table, one of the challenges in doing data prep, the tool of choice in data prep for data scientists is Python and pandas. Great, powerful tool, very ubiquitous, but has many problems around scaling, right? And so as you're looking at scaling the data that you want to leverage in training the data, data table is a great tool to be able to leverage to kind of be able to prepare, massage, and transform more data on a single node, right? So sometimes when folks look at doing scaling your data preparation efforts, there's lots of different tools to do that. Sometimes it says, oh, if I'm going to go via open source, well, Spark's the answer. Well, Spark's a great tool and definitely does scale, but can add a lot more complexity. So if you're sort of quickly reach the limitations with pandas, and you want to do additional transformation at a greater scale on a single box without having to necessarily move to a cluster, a data table could be a great choice for that. There's a tutorial that happened at the Pi Data Conference in LA. I think the YouTube video is out there. I can share it with Patrick that you can kind of check out. And we're looking at having some tutorials on data table, the Python data table coming soon.
Great. All right, Raphael, if you can answer this in the next 30, 40 seconds or so, this will be our final question. All right. Can you customize the way in which models are evaluated and compared to match your business situation?
Yeah, so I think the key there is looking at the score, right? So the way your business is evaluating your the model, the value of the model is a particular score. So the nice thing about having it this open and accessible model optimization platform is you can bring your own scores, right? And as you bring your own scores, you can leverage something that's out there in our catalog, so catalog.h2o.ai, or build your own so that we're using your metrics to drive the optimization of the model.
Awesome. Thanks, Raphael. So thank you, everybody, for submitting questions. If we did not get to your question, we'll be sure to follow up via email. And I want to thank Raphael for taking the time today and doing a great presentation. I'd like to say thank you to everybody else who joined us today. The presentation slides and the recording will be made available on our BrightTalk channel. And we hope you have a great rest of your day.
Thank you.